Welcome. So you're here to learn about Salt SSH for agentless automation, as you can see. So if you don't want to hear about that, please exit stage left.
And I also want to note before you go on, this is going to be really similar to my talk last year. So if you were here last year and are expecting vast new knowledge about Salt SSH, probably not the talk you want. So.
Cool. All right, go next. So just to intro ourselves, so I'm Nate Brooks. I'm a field engineer for Salt based in Madison, Wisconsin. I was an SE for, many, many different IT ops type companies. Spent 20 years on call, so I thought I'd actually go to a company where I didn't have to be on call anymore. So it's awesome. I've been at Salt about 9 months, and I have a strong dislike of silos, so I think all this was pretty fun. So, Colton?
Yeah, I'm Colton Myers. I used to be a SaltStack core engineer. Nowadays I work at Adobe. I also am the author of Learning SaltStack, if you're familiar with that book, and I'm base pi on GitHub and Twitter. So,
next. So we're going to go through use cases, what it is, how it works, wrapper functions, and do a lot of code dive. He's going to kind of really dig into it. So hopefully by the time you leave here, you will have an understanding of where it's used, how it's used, and what you can actually do with it. So anyone in here use Salt SSH in their core today for their deployments or anything with Salt? 1, 2. Who's never touched Salt before, or Salt SSH? Awesome. Cool. So let's get into use cases first. So the first use case of Salt is generally people don't want an agent. Some people have agent fatigue. They do not like them. They can't put an agent on them because of some policy or something like that. So Salt came up with Salt SSH to solve that problem. Next one is to Salt. So if you want to bootstrap Salt, there's many different ways, but Salt SSH can actually be used to install the actual Salt Minion on it. So if you're not actually able to use a bootstrap or build it into an image or something like that, you can actually use Salt SSH to issue those commands. And then the last thing that we use Salt SSH a lot for is Salt's broken. The minion's dead, we can't do anything with it, we need to connect into it. Well, wouldn't it be great if you could actually use Salt and the modules and functions based within Salt to actually fix the minion on that actual server? Anything I'm missing there? Any other use cases people are interested in for using Salt SSH? All right. I'll go ahead and back. Yeah, there you go. You called it out, thanks.
he said to compete with Ansible,
yep.
In case anybody couldn't hear.
That's one of their claims to fame, so. All right, well, I'll let him carry on, thanks.
All right, so what is Salt SSH? He already hit on this a lot, and it's really pretty obvious, but normal Salt uses an agent and connects over ZeroMQ. So Salt SSH was created to connect over SSH. It's designed such that it will leave no trace on the target system if desired. And it's designed to have feature parity with ZeroMQ Salt. We're going to put an asterisk there, and we'll hit on that asterisk later. It's actually pretty close to feature parity, but there are definitely some performance implications that we'll talk about. So before we really get into things, when we start talking about Salt SSH, people, and I start calling things minions, people sometimes be like, but it's not a minion, there's no Salt Minion installed on the system. I'm going to call them minions. So I'm not going to try to say hosts that we're controlling with Salt SSH, or I'm just going to call them minions. And in this case, the minion is not installed on these machines, but we're still just going to call them that. So master and minion, yes, there's no Salt. There's also not a Salt master installed, but we're gonna just call them masters and minions. All right, so we're just going to jump right in and just play around with Salt SSH for a minute. And because I'm insane, I decided to do a live demo. So, install. Just kidding, don't install. Yes. F you, just get out of here. I tried to cancel and it was like, no, I don't want to cancel. All right, so Vagrant, SSH. So I just threw up a couple of Vagrant boxes here, and again, I'm going to call it master here. And so what we're going to do is we're just going to pip install Salt SSH. Because that's really the easiest. Since Salt SSH doesn't have any non-Python dependencies, we can just pip install it, and it works pretty well. Sweet. All right, so Salt SSH is installed. The disadvantage of pip install is that we don't have some of our standard paths and so forth. So I'm just going to make a couple of those. We're going to make dir etc salt, and we're going to make dir var log salt. That way we can get rid of some errors. All right, so in order to use Salt SSH, we need to tell our master where its minions are. Because the minions are not connecting in, like in Salt, the master has no idea where they are or what they are or how many of them there are. So we need to give it that information, and we do that via the roster system. So we're just going to go etc salt roster. And this is, by default, we use what's called the flat roster, which is just flat files in YAML. So we're going to call this minion. It's a very generic name, but I don't care. The host is 10.0.0.201. The user is root. And there are some other things you can put in here. You can point to a specific private key. You can turn on sudo mode so that if it connects to as a non-root user, which is a requirement, it can then sudo to do the actual commands that it needs to do, that kind of thing. But we're just going to connect as root because it's easy. Oops, that was. All right. So now our master knows about our minion. So let's try. It's the moment of truth. All right. So we have one minion defined, and we're going to ping it. It says, all right, we went out to ping this minion, but permission is denied. Do we want to deploy the Salt SSH key? And yes, we do. So we type in the password. And boom, we got true. And now, if we do that subsequent times, it's just a test.ping. It's working now. So there's one step that I skipped here that maybe, actually, let's just do this really quick. Vim, known hosts. Deleted. All right, so because I SSH'd into it earlier, I already accepted that. So if you try to SSH into something and it doesn't have a known host, it says, oh, the host key needs to be accepted. To auto-accept, run Salt SSH with the -i flag. And if you want, you can just run Salt SSH with -i forever now and always. I think you can actually set it in the master config as well if you want. But, you know, that's less secure, so whatever. But, OK, now we've accepted it, and now we can take the -i off again. And we're back to working, theoretically. Don't choke on me now. All right. Whew. All right. So Salt SSH, we test.ping. That's pretty easy. Let's check out. Okay. So do we have access to grains? Yes, we do not. Grains.items is not available. That's not cool. Oh, what version did it install? Thank you. Oh. See, I get in the I fat finger things all the time. Oh, that should be fine. Oh, grains.items. Sorry. Whew. Scared me for a minute. This is what I get for doing a live demo. But we have access to all of our grains. So we have our CPU flags. Let's go find the OS stuff. That's usually what we care about. So this is just an Ubuntu 14.04 machine. It's running on VirtualBox. It's normal stuff. All right, so we can run commands. Oh, Salt SSH. I'm just going to alias that. Command.run, ls temp. Why not? That's going to be, let's just ls/ because that actually give us something. Okay, so we can run all of the, basically everything that's available to Salt is available to this minion. Obviously, these commands are still running on the minion, and so you know, we can't run things for which we haven't installed the dependencies. But we can install stuff. We can say, okay, I want to do package.install. I don't know, htop. That's usually not installed. And I don't think it has any dependencies. Yeah, okay, perfect. So we can install packages. All right, so that's Salt SSH. That's how you get installed in, a few seconds here. So how is this working? So there are a couple things going on here. When we run Salt over SSH, we say that the transport is SSH, but that's a little bit of a I guess it's valid, but we don't open an open SSH connection where there's two-way conversations or anything like that. What we do is we have a very simple shim script which is Bourne shell compatible, and that script actually loads a more complex Python shim, which we send down. We base 64 encode it, and we send it down with this shell shim, and that gives us the ability to, okay, we check, is there an available salt call runtime on the machine? If not, we need to deploy Salt SSH, and we're going to talk about that deploy in just a minute. And so it does a lot of that checking for us. And what we do is we actually package up the salt code that's on the master, and we package up what we call salt thin. This is a thinned down version of Salt with just its Python dependencies, and we shove all of these Python dependencies and Salt into a tarball, and then we deploy it to the temp directory on the Minion. And you can actually define where you want to deploy it. If you don't want to do it to the temp directory, you could do it to the home directory or whatever else. But by default, it does it to the temp directory. It randomizes the directory so that, for security purposes. And then it actually deploys a working version of Salt call. So we're actually, what did I have next? Yeah, okay, we're going to talk about that in a minute. Oh yeah, we should talk about that. We'll do that in just a minute. Okay, so let's go over, that's not what I wanted. I want this. Let's make that big. All right. So let's go into the Minion and just look here. So let's go to the temp directory. Let's make us root first. So if we go into temp and we look, there's that SSH thing. I actually don't think that's Salt related. Yeah. But what we actually have, if we do -a, is we have this .root _ d2fedf _ salt. So let's go in there. And in here we see, okay, we have a series of dependencies, backports _ abc, markup safe, jinja2, all these different things. And then we have Salt. If we look in Salt, we can actually see, okay, this is the Salt code that we know and love. We also have Salt call. So actually, if we can actually run it right here, we can say, okay, Python Salt call -c dot -- local. I think that's it. Test.ping. And we have Salt working on our machine. So earlier I said Salt leaves no trace if desired. Well, by default, it's going to leave this stuff down there so that subsequent commands are faster. We don't want to deploy this every single time. But if you want, you can actually deploy it every single time. Let's actually go back over here. That's not what I meant to do. And just delete this directory. And then if we go over here, we can actually use another flag, -w, capital W. Oh my gosh. Test.ping. I lose all ability to type in front of people, and yet I continue to do live demos, so whatever. So Salt SSH -w is designed to, I think it stands for wipe. I'm not actually sure. Is that right? So basically, when you use -w, it will deploy to a completely random directory in temp every single time. And then when it's done, it will clean itself up. So it actually leaves no trace on the Minion. So this, okay, Minion true. And if we go over here and look, temp, we need to do ls-a. We see there's nothing new there. And actually, if we go over here and we say, let's do something longer, like test.sleep 10. And then go over here and we say ls-a. We can see, okay, we have this .9479D1. That's actually where Salt is running out of. And if we wait 10 seconds, it's gone. So that's -w. We're going to leave it out there because we don't care if it's leaving no trace. All right. Oh yeah, and then the other thing I want to talk about was -r. So you can also use this as just, because we've already deployed a key and we have easy access to all the minions, you can actually command your minions with just raw commands. So rather than, so we do -r, which are going to target all our minions, and then we just run a command like, IP ifconfig. And we see it just runs this command, and we get our ret code and our standard error and our standard out for just raw shell commands across there as well. So that's available. Anyway, so that's basically how that works. I'm not gonna. Oh, I guess I do want to code dive just a tiny bit here, because this is interesting. So if you're not here if you don't care about code, then just fall asleep for a minute. But let's go to client SSH, and we're gonna go to I want under init. So in here we can actually see our shim. So this is the shell shim, and it's just a string because we actually don't need a separate file. We actually use this. We actually format some different things into it, including this fancy right here SSH PyCode. When we actually deploy this, that's going to be base 64 encoded Python script, and the Python script is right over here. Let's go to SSH PyShim. So this is the shim that actually handles the, it checks if Salt is installed, and if we need to deployment, hey, we need to deploy, that's what this is. It checks various things. I'm not gonna talk in detail about this because it's a fairly complex script, but that's basically the way that we're handling this, and it's a little hacky, but it works surprisingly well. And yeah, any questions so far about that deploy process? Or do you have to use root? No. So you can. Just like with Salt, it will work without root, and you can actually use it without even sudo permissions. But a lot of stuff isn't going to work, right? You can't install packages, and you can't do all these various things. But if it's a requirement to use a non-root user that does have sudo, you can actually say, let's go back here and say roster. We can say, okay, we want user some dude, and we want to say sudo true. And that will actually say, okay, every time we run a command, we're going to go in as some dude, and we're going to do sudo to run our salt call commands.
It requires the permissions in that sudo orders file, so like
right.
The no password also needs to be set.
Yeah. I don't think so right now, but that's an interesting idea, so maybe we'll have to talk a little bit later. What do you mean?
Like as a raw command?
Oh yeah, well yeah. I mean you can through the raw shell you can pass it, but we need the ability to add it on to every command that is automatically run by Salt SSH, right? So that's what this is doing. It's saying, or that's what this is doing. No, because if I say sudo Salt SSH on this end, yeah, now I'm root on the master, but it's not going to be root on the minion. Right. Yeah. So if it was running as a non-root user, yeah, you could sudo in front of your command.run, but for package.installed, it needs to know to do that kind of
the
stuff.
roster file is the authority to tell Salt SSH how to get into that end node.
Any more questions so far? Oh, and by that, and I missed a huge point, which I should have hit on, and that is the fact that Python must be installed on the target system. We don't deploy Python. That's out of the scope of trying to just do that with a shim file. And so Python has to be installed on the target system, and that's the problem. Is that if you have a system, if you have a switch that just can't run Python, then you're out of luck, and that's when you would use a proxy minion. So basically, when you can't SSH and use Python, run Python scripts, that's where you need to use proxy minion because you're going to have some other method by which you manage that system. So.
Yeah, it'll actually take when he issues command.run, it packages up the command.py and actually sends it down to the minion to run. So it needs Python there. Takes the modules right and sends it down.
Yeah. I mean, yeah, tars that whole thing down, and then it has the. All of Salt is down there, so. Any more questions? All right. Let's go back to the slides here for a minute. So let's talk a little bit about architecture and the issues with this method. So ZeroMQ Salt, basic Salt, is push-pull. So minions connect out to the master, and then they retain an open connection at all times. And So this allows the minions to pull data. You can have a scheduler on the minion, completely independent of the master, that says, hey, at this time I want to run this job, and the minion will say, hey, master, I'm running this job, give me these files. This is super convenient because the minion at any time can be like, oh, I don't have this file, let's go fetch it from the master. In addition, the master can initiate jobs, and because the minions have an open connection at all times, the master can say, hey, I want you to run this job, and they'll run it immediately. A lot of other systems, do this via a scheduled pull, So if the master wants to run a job, it has to schedule it, and then the next time the minions pull, it runs the job. And it's really nice in Salt to have this immediate access to any of your minions. So with Salt SSH, you keep that immediate access to any of your minions. You can run a command immediately. It's a little slower because it's over Salt SSH, but the master can push these commands out, but the minion can't call out to the master at all. The minion has no access back to the master. And this has some unique challenges because all of a sudden, when I run a state run, usually the minion will say, okay, hey master, give me the top.sls file. It'll compile it and say, oh, I need these files. Hey master, give me these files. And it'll use those and it'll run the states. But for Salt SSH, it can't request any of those files. They need to be there at the time that we run the Salt call job because we use -- local. It just looks for local files. On that Salt call. So you definitely lose something when you go to Salt SSH. And I'm here to say, Salt SSH is useful, and there are definite times when you just can't use normal Salt for some reason. But if at all possible, use normal Salt, because normal Salt is really great, and you definitely lose a lot when you go to Salt SSH. So
I think people could realize that the use case of when the Salt Minion is actually broken using Salt SSH, being able to start it, services, look at the logs, pull other info, rather than SSHing into the box.
Good point. All right. So how do we? So I talked a little bit about the fact that we need to have all those files on the minion. So how do we do that? And we do that via what we call wrapper functions. So wrapper functions are special functions that are designed to run on the master, or at least begin running on the master on behalf of the minion. So a lot of these, the big ones are CP. So obviously, I can't go to the minion and say salt call cp.get this file from the master because the minion can't just request files from the master. So we start that on the master and we say, okay, master, the minion is about to request this file, and we send it down with the command, and then the minion can deploy that file. I think actually cp.get for Salt SSH is actually just an SCP command basically. It doesn't actually ever hit salt call on the minion because we can just send the file down. The big one, I'm going to ignore most of these. This is just a list of the current wrapper functions. The big one is state. And I'm gonna save that code dive for a minute. I'm kind of switching this around a little bit. The state system in Salt SSH is the big problem with the difference in the way that minions in Salt SSH work. Because like I said, in normal Salt, when you say state.sls such and such, it doesn't send any files down immediately. It just says, hey, minions, run this command. And then the minions say, okay, running. Oh, I need this file. Oh, I'm templating, and it imports this file. Hey, master, I need this file. And it just does that, granularly with every file that it needs. And it works really well, but all of a sudden we can't do that in Salt SSH. So the state system actually compiles on the master. And the way this works is, for each minion, we go out and we get the minion's grains, and we generate the minion's pillar, so the master has all the information, and then we basically template those files all on the master. If like in a Jinja template, you call a Salt execution module, it'll actually create a Salt SSH session and go out and get the results of that module from the minion, so it can continue templating. It completely templates it down to, for those who are fairly familiar with Salt, the state system compiles from the YAML to high data and then to low data. And it actually compiles all the way down to the low data, which is just a giant dictionary of data. And then it inspects that low data and says, are there any references to Salt-owned files? Salt : / basically. It says, okay, in this low data, we're requesting this file and this file and this file and this file. So let's package all those up, package it up with this low data in what we call a state package, and it's just a tarball basically, and send that down to the minion. And now the minion has all the information it needs to run the state package. It has all the files it needs, and so we actually use state.pkg to run this state run. Okay. Should have had this up just a minute ago. So cross-calling creates new SSH sessions. This does have a couple of issues. If you have say you're doing a file.managed, and that file is Jinja templated, and inside of that you import a Jinja map for easy use of, I want to say, okay, based on this grains, I want to filter this map. So it's pretty near to impossible. It's technically possible, but it would be very difficult for us to go through and say, okay, inside of this file, it's templated, and it's going to request this other file, and we need to send that down with it. So the way we solve this is with these extra file refs. And basically, this is a configuration option as well as a command line option that we can just say, we're going to run the state file, and you just need to send down these extra files. Yeah, you don't know about them necessarily. You might not even need them for this run, but let's just send down these extra files so that if any of our states need them, they can use them. And that's how we handle those kinds of things. And then also, we're going to talk a little bit about the mine. The mine in Salt SSH works. Don't use it because. So the mine is designed for easy access for other minions' data. So this minion is going to need a list of all the minions who have some setting or some are in some IP block or something. And so the minions every minute or so send up the state of the master collects it, and then the minions can request that data, and it's very quick and it's fairly up to date. But because minions can't just give that data to the master for Salt SSH, every time you call mine in a state run, it's actually going to go out to all those minions and retrieve that data. And because I didn't have time to do this properly when I implemented it, it doesn't do any sort of caching or anything like that, which means that if you have 500 minions that are going to do a mine.get against all other 500 minions, you're going to open 25,000 Salt SSH sessions. Because each minion is going to open 500 SSH sessions. So it's something that needs to be fixed. It technically works, but not at scale at all. So the mine doesn't make sense in Salt SSH land. It really doesn't. And the only reason it's there is because we wanted to be able to say, hey, you can take any state from Salt and use it in Salt SSH, and it works. And it's while technically true, there are definitely gotchas. So that's my rant on the mine in Salt SSH. So let's go demo Salt SSH. Sweet, thanks. All right, so let's go over here. All right, so we need to serve salt. All right, so let's just make a test.sls file here. We'll do install htop, even though I already did that. It's just easy. Name htop, that's fine. And then let's say put that one file in that one place. I like to just do random crap in that line to show people that you can just do whatever you want in that line. Name, let's put it in temp, my file, source, salt : / my file. All right, it's a pretty simple state file. We're not trying to learn the state system here, but we're just going to install a package and put a file in place. So Salt SSH state.sls test. Yeah, you're right. It's going to be like, oh, we can't find the file, but no, they can't find the file. So okay, my file. Foo bar. All right, put the file there, htop is installed, and for all intents and purposes, that was pretty quick. I mean, what's going on underneath is we are going out to the minion, getting all the grains data, generating the pillar, compiling the state run on the master, putting all these files together, tarring them up, sending them down to the minion, saying, hey minion, run this out of this tar file. And all that happened, and it's not very, it's slower than running a state run on normal Salt, but it's there. And if we change my file to Baz, it'll send down the new file and we get the diff and everything. And for all intents and purposes, we're just running Salt. It's just a little slower. So that's the state system. Does anybody have any questions about running states in Salt SSH or anything else that we've talked about so far? That's an interesting use case, and I don't think we support that at the moment. You could get it to work by doing, if you already have Salt installed because you're in masterless mode, you could just do Salt SSH -r and call Salt call state.highstate.
You'd still have to maintain that roster
Right.
file is the thing.
Right. We assume that we know about our minions and that kind of stuff, but dash local. So you could do that. It's not great, but that's actually a really cool use case, and we should definitely support that. So open a feature request, ping me on it, and maybe sometime we'll get to it.
Work for Salt still.
Yeah. I'm still working on Salt at Adobe, so it's okay. Any other questions? All right. Let's go back to the slides, see what else we have here. All right, what's missing? The biggest thing that people run into is they're like, oh, well, I want to target by grains. And that is definitely doable. We just haven't done it yet. The issue is, the master doesn't, in normal Salt, again, the minions reach out to the master. When they first connect, they say, hey, master, here's my grains. And the master caches those, keeps them available. In Salt SSH, we have to reach out to the minion and say, hey, give us your grains. And we have two options. We can do that every time we run a command, which is not ideal, or we can cache it. And we should need, because the minion can't update its own cache, we just have to have cache validation and that kind of stuff, and we just haven't gotten around to that yet. So right now, you can target by glob, you can target by list, and technically there's node group support. It's not real node group support. It is special, let's see here, it's SSH_list_node groups. And you put that in your master config, and it's basically just comma-separated lists of minions. Because there's something to be said, since you can't target by grains, you need a way to group your minions in such a way that you don't have to pass in a giant comma-separated list of minions every time you want to run a command on a specific set of minions. And so you can use these special list node groups to just set up those groups. But we can definitely make that better, just haven't yet. Obviously, you lose the reactor and event system because the minions can't fire events to the master. If you have a master running on the machine that you're running Salt SSH on, the return events, when we get the returns, will actually still be fired to the master bus. But you can't do any minions just running, it notices a file change, fires an event. You can't do any of that with Salt SSH. And then obviously Syndic and those types of topologies also don't work on Salt SSH. Theoretically, you could set up a tiered setup with Salt SSH, but it's not something that has been. Salt SSH is while it's a first-class citizen, it's not really a first-class citizen, if that makes sense. We want to make Salt over ZeroMQ the best it can be, and while Salt SSH is cool and is useful, we just haven't spent as much time with it. So, any other questions? Say again. I do not know. I am not familiar with SDB. I know it exists, but I have not had a chance to look into it. So,
what's the use case that you're trying
You had a question? You know, I have not tried through Bastion host. I know we've had issues. We do support. You can, if you have sudo with require TTY true, that actually works. You just have to put TTY : true in your roster as well. So we do support some of the weirder security cases, but I have never tried through Bastion host, so I don't know the answer to that question. You just need to, yeah, it's a comma separated list of files and folders. So if you're not worried about sending down some extra files, you could technically just do that to your whole file roots and just send your whole file roots down every time. But you know, in most cases, there's going to be very limited. Most people don't need that. Unless you're doing advanced templating inside of file.managed files that imports other files, because the template file is going to go down fine, but anything it references inside of its Jinja is what's going to be there. So it's kind of one of these things you set up once when you need it. When you use those special use cases, you just stick this extra file refs in there, and it sends down an extra couple of text files every run, and oh well. Right. Yeah, I've been trying to figure out a better way to do this without sending down everything, but it's so hard to like go into these files and parse these. I will note if it's in an SLS file, like you have mysql.sls and that imports a map.jinja, that works fine because that all happens on the master. All of the templating happens on the master. So any SLS file, any files it references, that's all good. It's just if you have a file.managed and you say template jinja in that file.managed and that imports files, if that makes sense. Right. Or yeah, that's another good solution is if you just use context for that templating. That's actually a really good point. Then you avoid this whole issue. Any other questions? All right, I think I was reading in the we have a couple minutes, right? Yeah, like 6 minutes. I was reading in the description that I was supposed to talk about custom dynamic roster modules, and I didn't know that until an hour ago. So I should probably have read that better. But I'm going to talk about that briefly. So if that interests you, you can get basically the idea is you can get your roster data from any source you want. So we're going to do that. If you leave, I won't feel bad. But that's what we're going to do for a couple minutes here. So. All right, so we're going to start by heading over here, and we're just going to look at the flat roster, which is the one that we use by default. Roster flat. All right. So every roster module needs a targets function. It takes a target, it takes the target type, and I don't remember what we pass in for star quargs, but it needs to take star quargs as well. All right, so let's get roster file here. Where does template come from? Oh yeah, okay. File template. All right, so basically we're going to just get the roster file from ops, which is ops contains you can get the roster file from different locations, and so it gets the roster file, it compiles it. The roster file actually does support Jinja, and then basically it says, okay, we want to check the targets inside of this roster matcher function. So roster matcher says, okay, give me some data, and then it says, okay, I just want to check for the target type. So we have all these functions: ret, target type, minions. And so glob minions, it supports globbing. We just say, okay, for minion in self.raw, which is just a Python dictionary that we got from the YAML, we want to see if it matches the glob. We want to get its data, and then return that list of minions. You can also do PCRE. I forgot that's supported, so we can use regular expressions. We have the list matcher, like I mentioned. We have this special list node groups, which is defined with SSH list node groups. But basically, we just need a way to get data that looks like it actually looks just like the data in the flat roster. It has a minion, and then it has that minion's data. It's host. It supports host, priv key, sudo, tty. It even supports passwords. So if you want to put, I don't recommend this, but if you want to put plain text passwords in your roster, then you won't even have to use SSH keys, and it will just use that to authenticate with the minions. So if we look in here, we actually have a bunch of rosters. We can actually read in Ansible, Ansible's version of rosters. I don't know if they're called rosters. I don't actually know. We can get it from Salt Cloud. We can get it from. We can actually get it from scanning So we actually wrote a port scanner in Salt SSH. So if you use the scan roster, you can actually give it an IP block, and it will just scan for anybody listening on 22 and try to hit those minions. Let's try that really quick, just for kicks and giggles. We should be able to scan our 10.0. whatever. Let's do -- help here. Scan ports, -- scan ports, but we need to pass in. Is it -- roster? Yes. Okay. So let's do salt SSH -- roster equals scan, and then -- scan ports. I don't actually. Oh, we're going to scan on 22, so that's fine. But the ports we want to scan, the IP block that we want to scan is 10.0.0.0/ what do I want? 24? I don't know. That'll be fine. Let's just try it. Test.ping. Ooh, it found others. That's not good. Oh, it's going to itself. So 200 is us. .1 I think that must be my laptop. But I'm not 100% sure. Let's just say, but where is 201? Oh, there it is. Oh yeah, so 201 worked. And the other two were like, oh, we haven't accepted this. So let's just accept those, because why not? I'm pretty sure it's my laptop and the local system. Okay, we don't want to deploy to .1, because I'm not going to do that. But we can deploy to ourselves. Why not? Oh, because I don't know the password. Password. That's why. And because, I don't know why I'm doing this. This is not interesting. Ha 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 ha. All right, SSH, restart. Just want to prove to myself that it'll work. No, yes. Yes, so Salt SSH actually creates its own key pair, and by default it wants to auth with that. I'm actually working on a fix that I started last night and I never got around to finishing because the party happened. For an option that will default to your home directory instead of the other key, because a lot of people want that because they already have SSH set up. They can already SSH to all these machines. And so why not use that instead of its own key? So yeah, that'll be supported soon. But so this actually does not generate a roster. All it's doing every time that you run this, it will scan and try to hit every minion that it scans successfully. Ideally you would create maybe a little script that does this and then dumps a roster file or something, but it does not do that currently. But yeah, so you can get this data from whatever. You could get it from a MySQL database, or you could get it from your CMDB. You could get it from whatever source you wanted. You just need to write a little Python script that goes and fetches that data and then handles the targeting on that data. So, any other questions? For the scan roster, for example? No, the roster would have to do its own caching currently. Say that one more time. Sorry. Oh, so now, so it deployed, so on 200, so 201 was working from the beginning because we've been doing that all night, or all day. What time is it? But 200, we just deployed the key. So if we do that again, it'll still ask me on .1. So it doesn't store passwords. It actually deployed the key to the target's, I don't remember what the file is called. Authorized keys. I'm just spacing on basic Linux stuff, guys. So I'm going to call it. Any other questions? All right, thanks, guys.